Friday, the 5th of September, 2025, and it's been at least a day since I've done a video again, so I wanted to pop in and give my interpretations of international news and updates for the week. Then also talk about Terrella experiments, Birkeland, and some research I've been doing on plasma physics, particle physics, etc. And it's been so interesting to me, and so my apologies if it's a bit nerdy for people, but I'm going to talk about the updates on stuff before I get into what I was looking into anyway. So this was interesting.
Fuck NATO right in the ass with one meeting with Xi Jinping of China. All the oil that Russia had been selling to all of Europe, for their home heating oil, he just cut one deal with Xi Jinping. All that oil, it's now going to China. It's going to get pretty cold in fucking Europe. And then Putin was walking with Xi Jinping, and that Xi Jinping, that Bond villain, he said to him, he goes, we can live to 150 years old now by just taking people's organs. Organ harvesting, yeah. Yeah, you just said that shit right on a hot mic. And Putin just kind of looked at him and was like, wow, dude, just fucking gonna throw that down, huh? Putin didn't say shit. Ukraine? Fucked. They shot a missile into Poland. They've blown up Hungary's fucking oil pipeline. So Russia hasn't attacked Eastern Europe, but now Ukraine has. And like the ex-fucking prime minister of Poland, he's like, oh yeah, I totally knew that Zelensky fucking shot that missile in here and killed some Polish people. Like, this fucking NATO's fucked, Europe's fucked, Ukraine's fucked. Russia's going to do whatever they want. They've already got people in Odessa, and Odessa is the last port city that Ukraine has. So if Russia takes Odessa in Ukraine, then Ukraine will basically cease to be a country, because without a port, what the fuck are they going to do, right?
Yeah, and NATO has been interfering with Ukraine now for over a decade. I know that for a fact. And not helping the situation and pushing a lot of propaganda and psychological operations, people that don't even realize they're doing it, people that were on the ground, not even talking to local sources, people on the ground from other agencies saying things that were going against what they were sharing, including also reposting messages about events coming from literal paid influencers during these major events as well, almost getting Article 5 declared, like I've talked about before. And so when he's talking about the Ukrainian air defense, they said it was an accident, but first they wanted to blame it on Russia. And so did NATO, including the chief of defense staff at the time, who I said, I got my LinkedIn account removed during that time because I was calling it what it was. I was like, this is Ukrainian air defense. There's no reason for NATO to declare Article 5 or anyone to get involved in a war over this. This is a proxy war that's only benefiting the military, pharmaceutical, industrial tech complexes, and especially these major like Raytheon and Lockheed Martin and General Dynamics and the oil industries and affiliates. So a lot of these comments were interesting. The EU was too busy importing the third world. But yeah, so the pipeline getting attacked in Hungary, that was Ukraine as well. And yeah, just very interesting. Why?
NATO is just flushing it all down the toilet. They're all fucked. Putin, he ain't dumb. Ukraine, you're so fucked. To the rest of you, good luck. Long live the Republic. Putin just...
Yeah, so that was interesting. I've talked about Russia, Ukraine, NATO, and Europe literally for years, even before it was it escalated. Anyway.
I had facial feminization surgery. I had sex reassignment surgery. I was on HRT for 17 years. Now I'm on a combo dose because I can't go off. I have multiple health conditions from transitioning young and for transitioning for so long.
Wow. So what was it for you that kind of woke you up to this isn't what I should have done?
I found out that homosexual transition was environmentally caused in almost every single case by childhood sexual assault or by internalized homophobia or failed boy syndrome. 92.5% of trans-identified males are straight and bisexual, and the only explanation for a straight or bisexual man to transition is autogynephilia. So, from my perspective, I went there and I was given a blanket diagnosis given to anybody who has a body issue as a child nowadays.
You know that your message will probably make them angry. Why is it important for you to be here?
Because people are being lied to when they're being diagnosed. They're not being diagnosed with what actually causes the gender dysphoria. They're just being diagnosed with a symptom of a problem. And there are multiple problems that cause those symptoms. And when you don't appropriately diagnose people, you lead them into a life of ruin. All of these interventions are permanent, they're irreversible, and they lied to me. I want people to know that they're lying to people. They're not diagnosing autogynephiles as autogynephiles. I have friends who medicalized all the way and are self-admitted HEPs who were never diagnosed with the
Autogonophilia is, I've talked about this before, are men who there is a fetish or sexual fixation on not only dressing like women, but being in women's safe spaces. There's an arousal there.
reason they feel this way. They were just transitioned.
Who do you blame for this sort of fast tracking of medicalizing children?
I think after gay marriage was won, there was an empty hole in gay politics. We had gotten everything we wanted, and I think trans jumped into all of the orgs that were associated with the gay community, and they lobbied to make gender identity a protected thing. They started doing that in the 90s, and I think this is a byproduct of the trans community intentionally watering things down and lobbying so everybody can have access, and they don't care about the people who are indoctrinated, who are harmed by this loosey-goosey system where you can walk into a therapist in 15 minutes and be given a gender dysphoria diagnosis.
What do you think it'll take to fix it?
It's going to take lawmakers to step up and shut it down. I had facial.
Yep, and you had people like Bonnie Critchley or whatever her name was that was trying to amend bills and have it where this wouldn't be something that wouldn't be accessible to minors, to children. And so, again, things that I've talked about for a while. And I will reiterate that I don't think that trans people shouldn't exist. Or the ideology shouldn't exist. I think it's a very, very small percentage of the population and has throughout history of people who identify or even present in a lot of cases as well as the opposite biological sex. Blair White is an example of that and has confirmed that she has gender dysphoria as stipulated in the DSM-5, which is being updated right now. And it's either the 2012 or the 2015 version we're going off of now. But to affirm clinical diagnosis in so many other instances, it's maladaptive and it's actually destructive. So you shouldn't be affirming someone who's diagnosed clinically with complex PTSD, or someone that has bulimia or anorexia or bipolar disorder, et cetera, et cetera. These are all clinical diagnosis of mental health conditions as classified in the DSM-5 and recognized by major psychological institutions, medical institutions. And so, and calling it things like gender affirming care instead of conversion therapy, and not looking at the longitudinal studies that have come out, the increase in people that are identifying as being in the LGBTQ plus community. A lot of Gen Z now, like almost 20% now, are identifying as being a part of that category. And you look at the other categories like Gen X, boomers, millennials, it's significantly lower. And so we also have to look at the indoctrination piece, these forced curriculums that are being pushed within the schools at a very young age, including even at daycares. And this is the formative years for children, especially between the ages of 5 and 8, as per Piaget's model, et cetera, the levels and stages of cognitive development, and where our neurons they're growing at accelerated rates during that period. And these are very informative periods during our years. So if we're being introduced to ideologies or cultures that are not the norm, I'm trying to be a little bit politically correct here, but seen as deviant from societal norms and values and morals and ethics, etc. That's not something that should be introduced at that young of an age, because it shouldn't be something that is normalized, where we're trying to normalize these maladaptive, more deviant behaviors within societies when we've seen throughout history that this does not help, right? And anyways, I'll just keep it at that because I want to get into the science of stuff. But before I do, let's see what else I have here, because I just share a few things.
Well.
Oh yeah. On COVID.
What we discovered is that somebody in the federal health agencies, this interagency communication,
hid the signal. They admitted there was a signal on myocarditis, and they hid it. They didn't warn the public. They didn't warn doctors. So that's just one instance of corruption and lies told by the CDC. We've got a lot of others we'll be rolling out, okay? So we held our first hearing in front of a subcommittee investigation on that hiding of the signal of myocarditis. We've heard a lot of studies, okay? As I've looked into science, it's been thoroughly corrupted. Here's data, and I'd like to enter this sheet into the record. I've been publishing this chart for, since really early 2021, when I'm on, for example, talk radio shows and they talk about this, they get deplatformed, or they were, because all the censorship during the Biden administration. Here's the facts. The VAERS system that was touted in October of 2020, this great safety surveillance system on COVID, a few months later, when they didn't like the results, they started denigrating their own system. But VAERS shows that there have been 38,742 deaths reported on VAERS worldwide associated with the COVID vaccine. 38,742. 9,252 of those deaths occurred on the day of vaccination or within 1 or 2 days. Again, I agree with you. Nobody knows how many COVID deaths were because the information was completely corrupted. Nobody knows how many lives were saved by the. I think most people, okay, if you're vulnerable, raise your antibodies, reverse severity, fine. There's not any good study on that. There's just information out there, just claims being made. This is hard evidence. What we discovered is that CDC, somebody in the federal health agencies, this interagency communication, hid the signal. They admitted there was a signal on myocarditis, and they hid it. They didn't warn the public. They didn't warn doctors.
And these studies that he's talking about, these are actual scientific studies that were done. And this is what I had been sharing for years as well. I gave the links to the studies. I emailed and reached out to literally all levels of government. I've shared this before in videos and completely gaslit. They knew, Chrystia Freeland knew, Vera Etches, Anita Anand, Teresa Tam, Marco Menichino, all of these people that were experts in cabinet and refused to even acknowledge or follow up. So just because I was looking at Jubilee and looking at, was it Michael Knowles? Anyway, he was talking to 20 people that are part of the trans community. And one of the arguments that kept on getting brought up by people was that the majority of assaults and sexual assaults that are happening towards women are by cis men. And then it was said specifically cis white men. And I have heard that a lot. And so here's my take on that when we're saying that we don't believe that men should be in women's spaces, not only on the sports teams, because again, there's an unfair biological advantage and hormonal advantage, but also not having access to the locker rooms or bathrooms. And so my argument to that was that if you look at the number of sexual assaults and assaults that are committed, what percentage are by men, you see that an estimated 91% of victims of rape and sexual assault are female and 9% male. Nearly 99% of perpetrators are male. Nearly 99% of perpetrators of assault and sexual assault are males. This is the point we're trying to make. It doesn't have anything to do with being cisgender or not. It's allowing these safe spaces for women and only women and children, girls, little girls, from men. Okay, and so because of these reasons that I'm just laying out right now. And I know that I'm cycling back there, but I did want to make that point because that should have been made by Michael Knowles. But anyway, he did have a lot of great arguments. And let me see, I'm just going to go into my messages to see if there's anything else. No, all right. I don't even know where to start with the book, with the article, with the YouTube videos. I think I'm going to start with Grok. Okay. Because over the last few days, I've been doing a lot of research into my office. And I've also been canning different types of soups and purees. Harvesting. Okay, I was even looking into like different religious events that happen throughout history. Let's see here. I was looking at different types of degrees in the US. But before that, let's just see here. All right. Okay, so Christian Birkeland, a Norwegian physicist, 1867 to 1917. Oh yeah, and I don't even know how I fell upon this, but my question to Grok was the Northern Lights unveiled, Christian Birkeland's Terrella experiments recreated. So I don't even know how I came across that. But again, I was just looking through archived works, and I was reading. Actually, no, I think it's because I was reading a book over the weekend on electromagnetism in the dome and projections and membranes. And anyway, and I think maybe that's how I came across his work because of his interpretation of the auroras. And I thought that was very interesting that he was using electricity and magnetism and the Terrella being magnetized and then using cathode rays and then being able to recreate luminaries and then these like even the zodiac belt and things like that. And so I was looking at a lot of his work after this and different books that he made that were translated and then different other scientists who reinterpreted his work. And he's very much aligned with my theory on this universe or cosmos or whatever you want to call it, this simulated environment. And so please take a look at this guy if you haven't already. So pioneered the understanding of the Northern Lights, Aurora Borealis, through his groundbreaking Terrella experiments in the early 1900s. These simulations unveiled the auroras by demonstrating how charged particles from the sun interact with Earth's magnetic field to produce glowing atmospheric displays. The Terrella, a small magnetized sphere representing Earth, and again, I don't believe him with that. Like I do believe that the toroidal fields are what create this spherical shape or this cosmos being contained like this dome. But I believe that where we're experiencing our existence here, it's where it's being projected on the flat plane of inertia. And I think it's all connected. Anyway, the Terrella, a small magnetized sphere representing Earth, was placed in a vacuum chamber bombarded with electron beams, simulating solar wind, and produced aurora-like glows, confirming geomagnetic origins of the lights. Original experiment details. Birkeland's setup involved a Terrella, typically 24 to 36 centimeters in diameter, with an electromagnet inside, in a glass vacuum chamber filled with low-pressure gas, simulating the atmosphere, especially at the higher levels. He fired cathode rays, electron beams, at it, observing luminous rings and polar glows mimicking auroras. Key findings. Equatorial rings formed when the Terrella was negatively charged cathode, simulating radiation belts. Simulating radiation belts, like the radiation belts around Earth. Polar auroras appeared when positively charged anodes. When positively charged, so brackets anode. So again, negative and positive. Due to electron and attraction to magnetic poles. This proved auroras result from solar particles trapped and accelerated by Earth's field, ionizing atmospheric gases. So ionization of the atmospheric gases being the fifth state of matter, which is plasma, if that's what you want to call it. Anyways, oxygen and nitrogen to emit light. His work laid foundations for space plasma physics, including the discovery of Birkeland's current, field-aligned electric currents in Earth's magnetosphere. Modern recreations. Birkeland's experiments have been recreated and expanded in labs to educate and advance research. To advance research. Notable examples: Planet Terrella, the Norwegian recreations, and NASA and lab simulations. And again, a lot of this is propaganda and artistic creations and renderings. NASA's Goddard Space Flight. I would love to talk to people that do this work, just for like a different perspective on how you complete the experiments, with what model to use. Yeah, because I do believe that this is some kind of an electromagnetic reality. Okay, so I looked at videos. I'm going to get into that. There's different papers out there on this as well. So Kirkland's Terrella experiments in the early 20th century provided empirical evidence for the electromagnetic causes of auroras, northern lights. Several ancient and historical scientists made observations or predictions that anticipated similar ideas about auroras as atmospheric phenomena linked to cosmic or magnetic forces. These early thinkers lacked modern tools, and I don't believe they lacked modern tools, but anyway, but described auroras in terms that hinted at particle interactions or field-like behaviors. So particle interactions that impact or manipulate the fields, right? Because particles create waves, just like Wi-Fi, like the signal, like a little dot in the waves. Throw a rock onto water, it creates waves. That can be projected on stones too that look like portals. Anyway, going on all these tangents. But again, this is grok. So there's still going to be a heavy piece in here where there's going to be misinformation that I have to ensure that I'm looking at as well. So Aristotle, in his work Meteorologica, Aristotle described auroras as chasms or glowing vapors in the upper atmosphere caused by exhalations from Earth ignited by celestial motion. I do believe that it's glowing vapors, but I do believe it's just based on like the different gases, the noble gases, the rare gases, and their interactions with the luminaries as they're traveling closer to them. And so as the sun travels through the Tropic of Capricorn, the equatorial ring or belt, and the Tropic of Cancer, it will impact the gases within this atmosphere or the ether in different ways, depending on what kind of rays are being emitted or projected, like gravitational versus radiating forces, yin and yang, positive and negative, expanding, retracting, centrifugal versus centripetal, and positive, negative. Anyway, and we can recreate this in labs as well. And so I'm going to show videos of this where different gases, how depending on how they're being manipulated, can emit varying types of light based on things like temperature, pressure, and density. Seneca the Younger. Aurora is visible in Rome as fires in the sky or beams of light. So speculating they resulted from atmospheric disturbances or magnetic protuberances. Anyway. Though without magnetic explanations, which should have been in there, people need to look more at magnetism and nuclear forces. Ancient Chinese astronomers, Chinese records such as those in the Shiji historical records by Sima Qian, described auroras as dragons fighting in the sky. I don't think so. Or red lights in the north, attributing them to cosmic imbalances or yin-yang forces. They noted patterns similar to Birkeland's solar terrestrial connections, with observations dating back millennia and predicting aurora events based on celestial alignments. So Galilei coined the term aurora borealis in 1619, describing it as sunlight reflecting off atmospheric vapors, foreshadowing Birkeland's particle reflection concepts. Edmund Halley in 1716 linked auroras to Earth's magnetic field, suggesting particles move along field lines, a direct precursor to Birkeland's work. I'm the same field as that. Okay, so ancient theories on auroras, northern lights, and lunar phenomena during the era of Eudoxus were limited by the lack of modern instruments, but several philosophers and astronomers proposed ideas that anticipated aspects of plasma science and Birkeland's Terrella recreations. So Eudoxus of Cnidus developed the first geometric model of the solar system with 27 concentric spheres to explain planetary motions, including the moon's orbit. He theorized that celestial bodies like the moon moved in harmonious spheres, rings, including Earth within this contained environment, and smaller and closer, and self-illuminating. Okay. Anaxagoras. No. Chasms are burning now. Anyway, some of this stuff is just, why is it here? I like Hypatia of Alexandria. She has some interesting views. She was a mathematician, scientist, astronomer. The moon is a reflective sphere in a harmonious cosmos, with light phenomena, possibly auroras, as manifestations of divine order or ethereal motions. I'm going more towards ethereal motions. Okay, let's see here. Okay, so connection to ethereal light and plasma-like ideas. Eudoxus spheres were conceptualized as made of ether, an incorruptible luminous substance distinct from earthly elements, earth, water, air, fire. This ether was thought to be transparent, yet capable of transmitting light and motion from the divine realm of earth. So I do believe that the luminaries are what creates the signs and the seasons and time, and what makes this whole cosmos function. And some kind of plasma. Ethereal emanation as a unifying force. Unifying force theories out there as well. I was looking into different degrees in the US, so I just gotta scroll past this. Okay. Oh yeah, JD Vance changed his name twice. People are making it into some kind of conspiracy theory, but it was because he first changed his name to his stepfather's last name at some point, and then to his grandfather's last name, and then his stepfather's, like one of his names or something like that. So that just popped into my head because that's more stuff that I'm seeing circulating on my feed, and it's like I don't care. I don't see anything sinister because of that. I don't trust the guy. I think he's connected to the New World Order stuff. And his friends and family are all benefiting off of all these proxy wars and major events that are happening globally or internationally rather. And yeah, they're profiting off of the destruction of societies, but whatever. Biodigital convergence. Friends with Peter Thiel. Okay, so then I was looking into fluorescent and phosphorescent materials. So phosphorescent materials are substances that exhibit phosphorescence, a type of luminescence where they absorb light energy, typically ultraviolet or visible, and re-emit it as visible light over an extended period, often glowing in the dark for minutes to hours after the light source is removed. This differs from fluorescence, which stops glowing almost immediately. The process involves electrons being excited to a higher energy state and then trapped in metastable states before returning to the ground state, releasing photons. So electrons and photons I've looked into a lot, but I think are negatively and positively charged atoms or particles, sorry. Okay, so types of phosphorescent materials, metal containing complexes. These include transition metal compounds with iridium or platinum that achieve efficient room temperature phosphorescence for applications like OLED display or bioimaging. They are often hazardous or expensive due to heavy metals. Purely organic materials derived from natural or synthetic organics. They are metal-free and eco-friendly, with recent advances enabling stable RTP through molecular design. Okay, so clustering of rigid structures to suppress non-radiative decay. Zinc sulfide, doped with copper for classic glow-in-the-dark effects. Okay, so I wanted to get into Berkman again. Okay, so let's see where I'm going to start. He argued that electromagnetism, rather than gravity, governs many large-scale cosmic processes. He viewed the universe as permeated by charged particles and electric currents, challenging the Newtonian paradigm dominant in his time. This cosmical electromagnetism theory posited that solar and stellar activity, including sunspots and flares, generate electric discharges that influence planetary atmospheres and space. He believed these forces drive phenomena across the solar system, from comets to planetary rings. I think this is all within this contained environment, that this is all happening. Berkman's most famous theory explained auroras as resulting from streams of charged particles, electrons, ejected from the sun, maybe, guided by Earth's magnetic field to the polar regions where they excite atmospheric gases to produce light. So the excitation of atmospheric gases. This was demonstrated through his Terrella experiments from 1896 to 1913, where a magnetized sphere in a vacuum chamber simulated Earth's field, and electron beams produced aurora-like glow. So this is absolutely an electromagnetic reality, like a magnetic core. I don't know what you would call it, or center. Is it a monopole or a dipole? He did a lot of testing on both, and using different types of materials that would be more magnetically charged or electrically charged, or positively or negatively charged. And I'm going to show that. Okay, so Birkeland's theorized field align electric currents flowing between the sun and Earth, carrying energy from solar wind to the atmosphere and causing geomagnetic storms and auroras. I think even like with the luminary's travel path possibly impacting areas because of the centrifugal forces, or the spin can make it where when you see, especially during the equatorial area, it's there's more hurricanes and cyclones and tornadoes that impact these regions, and as the sun's traveling, and so there is some form of resistance as well that's being experienced within these areas. Okay, geomagnetic storms and auroras. He estimated these currents at millions of amperes, linking solar activity, sunspots, to terrestrial magnetism. This laid the groundwork for space plasma physics and space within this cosmos, and the concept of solar wind as a current system. Very interesting. And you can look at water currents as well. Birkeland extended his theories to other cosmic bodies, suggesting electromagnetism explains comet tails as plasma discharges, Saturn's rings as charged particles accumulations, and zodiacal light as illuminated dust from solar electric activity. He collaborated with contemporaries like Svante Arrhenius on cosmical physics, arguing for an electrified universe where charged particles penetrate space. So I agree with a lot of what he's sharing, but his terminology, there are some things that I disagree with, like electrified universe. I think this is an electromagnetic or an electrified magnet. If we're going to call the universe a magnet, fine. Then we could say that it's electrified. And these forces working synergistically together, creating this cosmos. So maybe. Because it does amplify or increase the strength of field. And it could possibly be because of cathodes, just like these experiments he was creating as well. So I asked to share links to his translated works, and I got into a bunch of books there. So cathode rays are streams of electrons. Okay, so I think... Okay, so UV light can play a role in ionizing gases or enhancing plasma production, but it's not the end. Yeah, okay, I already knew that. Okay. All right, I'm going to share the videos now, because none of this stuff is too important, because it's just going to be redundant. So I'm going to get into the first videos I was like starting to look at. Know the glow. I've talked about cymatics, star in the jar, sonoluminescence. I've shared different laboratory experiments that Old World Florida has shared as well on his page. I've shared those videos. Very interesting. When you look at the different gases and how they light up, and there's different colors based on different interactions. Very interesting. Maybe. Oh yeah. Sorry, I just got a good comment here on from Nubik. I mentioned seeing Ken Wheeler, Theoria Apophasis. I think that's what he calls himself. Yeah, I've been following him for a number of years. Very interesting. I've emailed him and trying to have discussions on electricity and magnetism, and he has yet to respond. He's likely very busy, and but yeah, so I would like to have those conversations with him and talk to him about the possible shape of the Earth, because he talks about planes of inertia as well when he shows his magnetic experiments. And again, this guy is a genius. So, and I've said that as well. This guy is very brilliant, and he's written multiple books. So I'd like his interpretation on this stuff that I'm looking at, and magnetism. Yeah, great stuff. Phosphorescent, green liquid. So green, for the visible light spectrum, like you'll see it, it's in the center, just like the chakra systems. It has it where it's red, orange, yellow, green, blue, indigo, violet. The 7 different colors of the rainbow, or the visible spectrum. And then you've got the non-visible spectrum, which makes up even more of our reality. And so green is at the center, which is like the heart chakra, and there's no coincidence with that either. And we see more shades of the color green than any of the other colors. And so that is also interesting to me. And also it's going to come out on these videos as to why as well. So I'm just going to remove myself from the screen so you can read it. It didn't go through the whole list, which is lame. Okay, so I'll start from the scratch. Okay, so here we go.
I have over here a phosphorescent sheet. Now, at the moment, it's being protected from the light with a cover. So, the light's off, please. Okay. Okay, we have the sheet here. Now, this is material that, when it's exposed to light, will glow in the dark. So if everyone with a laser pointer can please shine their light on this. Oh, very good. Some of them are nearly hitting it, yes. Very good. So, okay, and if we now have the lasers off, what do we notice? Absolutely nothing. Okay, let's try some yellow light. So here I have a yellow laser, and no one else in the audience, I don't think, has a yellow laser. And again, nothing happens. Let's try some green light. Ooh, still absolutely nothing. Well, finally, I'm going to try a blue laser. Now, for a while, this was the only blue laser in the country until our professor of organic chemistry decided that he had to get one as well. Okay, and this one is actually able to excite the phosphorescent material. Now, you might not be able to see this unless you're very close. I have another light source in my pocket. This gives out some UV light. This has even more energy. And this allows me to write on it. In fact, I have another UV lamp here that's even larger. There we are, UV. So this light has enough energy to cause the sheet to glow. Okay, thank you. Very good. So the phosphorescent chemical in there was absorbing the light energy, but it needed to have good, strong light to do this. Red light wasn't strong enough. It didn't have enough energy. Yellow light didn't have enough energy. Green light didn't have enough energy, but the blue did. Okay. Well, we've got one more sheet of this over here. Now, to use this one, I need a volunteer, please. Somebody close near the ends. In fact, right on the end here. Thank you very much. Very good. Now then, okay, we're going to take a picture of you. So if you come over here for a moment, can I have the lights off, please? If you just stand here for the moment, we just need to take the screen off. Okay. Right. And just move this out of the way. Now, if you turn around, please, and face the screen. Hands up, hands up. That's it. Fingers out. On there. That's it. Lovely. You stay there. Legs apart. That's it. Legs apart. Very good. Right. Now close your eyes. Ready. Go. Now we're going to, that's it. You just stay still. And then move aside, please. Very good. Thank you very much.
That was cool.
Okay, so again, the light managed to charge up the chemicals that we have there. But actually, as I say, it's only part of the light that has enough energy to get this phosphorescent material to glow. Okay, we need at least blue light and possibly even some UV light. Well, I don't know if you were convinced by my blue laser demonstration over there. I have one more demonstration to show you that might convince you that blue light has more energy. We've got some tubes containing two gases mixed up. We have the gases hydrogen and chlorine. Okay, can I have the lights down, please? So this is we have to be very careful here because the light, we hope, will set this reaction off. Now, Chris is just putting the tubes in front of the light source here. I say, inside the tube, we have hydrogen gas and chlorine gas. Now, this as it is fine until we put some light energy into this. Okay. So with some light shining on this mixture, the light...
So I've looked into phosphorescence and fluorescence and different materials and matter and looking at the luminaries because I could understand if people were saying in mainstream scientific communities that the moon was phosphorescent and possibly being charged by the the sun. I could kind of understand that, even though there's ways that I could debunk that theory. Not a lot. But if you look into it, absolutely not is what mainstream media is saying, is that the moon is not made of phosphorescent material. Its composition is primarily silicate rock, minerals, and regolith. I don't know if I'm pronouncing that right. A layer of loose dust and broken rock fragments formed from ancient volcanic activity, meteor impacts. All of this stuff is nonsensical to me, and how it can be, how you can have reflected light on these surfaces from the sun. We don't see that being recreated here on Earth using the same materials, and so very interesting. So anyway,
it has enough energy
my
to
brain
break
goes in these directions
apart the
sometimes.
chlorine molecules into chlorine atoms, and this starts a rather vigorous reaction. Okay, so are you ready? Okay, first of all, let's try some red light. No reaction. Some yellow. No reaction. Some green. No reaction. And some blue. Oh, there we are. Good. We've seen how light can be stored up by the phosphorescent material there and given out later.
Okay, good.
Well, sometimes species can absorb the light and convert one color into another. So, for instance, we can take the UV light and convert this into visible light that we can see.
Like the sun.
So we can't, our eyes can't actually see UV light, but they can see other colors. And so here we have some tonic, just some normal tonic, but in UV, this glows really rather nicely. I have some fluorescein here. This glows rather nicely. I have some solutions here. These solutions contain organic polymers that were actually discovered in this laboratory. We have a red polymer, a greeny-yellow polymer, and a bluey polymer. In fact, they're not only excited with UV light, they're also excited using an electric current. We're going to see these in the future making up our televisions. We also have some minerals
making up our televisions.
Here, these minerals glow. This one gives out a rather intense yellow light. The other thing that I have here is a fruit bowl. Well, here we are. You can see the fruit bowl glowing. This fruit bowl actually contains uranium. Okay. We'll come back to that in just a second. Just while I'm here, if we have the lights up, please, I'll show you this £20 note. You can see in the corner of this
uranium
glowing there,
energy.
20. You can't see that in visible light, only under UV. We see the 20 shown.
Uranium mining for nuclear energy. I know I said that. It's very important. When I connect magnetism and magnetic energy with nuclear energy, this is the stuff I'm talking about. There's different forms of it.
There. Okay. Well, let's come back to my uranium fruit bowl. So uranium was one of the elements in the periodic table. And remember, this one is also radioactive. So perhaps my
Radiation.
fruit bowl is radioactive. Well, let's see. I'll just have to bend over here
Radiating
so you
energy.
can hear the Geiger counter. And yes, indeed, it is a radioactive fruit bowl. So we'll have to be careful what we do with that. Okay, so where it converts one form of light energy, the UV light, into a visible type is called fluorescence. And of course, this will be familiar to you with the fluorescent tubes that you have at home.
Okay, good. It's going into the
I
videos
have
I wanted to
a
share.
fluorescent tube here, just a normal fluorescent tube, sort of thing you've seen before. So this actually contains a small amount of mercury, the same sort of thing that Jean Picard discovered in 1675. This, with a little bit of electricity, gives out, well, it's actually mainly purpley UV light, but it can excite these phosphorescent coatings that we have on the lamps. Now, the lamp that I have on the top is rather a special one. On the end here, we have no coating at all, and you see the purpley color. This is due to the mercury UV light. And the three colors that we have here, these are the phosphorescent coatings that are used to make up the white light. So these three coatings are mixed up together, and we see these as the brilliant white in the fluorescent tube here. So this is how the fluorescent tube works. The elements for this, if we can just look on the last slide here, this shows some rather rare elements. We have cerium. If you can find cerium, oh dear, there we are, they're beginning to get there. Cerium, yes indeed, over there. Here's cerium. Europium. It's a rather rare element there. Europium. Gadolinium. Very good. Here. And terbium. And here's terbium. They also use a bit of yttrium, which is up here. Okay, so these are all the elements that are used in producing the light that we see in fluorescent tubes. If we look at the periodic table here, half of the elements, these are elements that we've discussed in this lecture. Over half of the elements in the entire periodic table we've talked about in this lecture that are involved in producing light in various forms. Well, this just about brings me to the end of the lecture.
Light and
So
sound.
what have we learned? We've learned that we can convert different forms of energy into light energy, electrical energy, and chemical energy.
This is a video about...
Oh, my dog is screaming.
Well, sometimes we've got some... I have over here...
All right. I don't know. Did I share this one? I'll see.
I have over here
Yeah.
a phosphorescent...
That one was definitely so interesting to me. Oh, the glow. Okay. So many things just go through automatically that I don't even want to listen to. Okay. Hydrogen explosion. Okay, maybe I'll just go to the cathode ray one. Yeah, I will do that.
In this video, we're going to talk about how J.J. Thomson discovered the electron in 1897 using the cathode ray tube experiment. So these days, we think about atoms kind of like this. They're made up of a variety of smaller subatomic particles. But in the late 1800s, it was all about John Dalton's model of the atom. In the early 1800s, John Dalton had proposed that all matter, all stuff, was made up of tiny, indivisible particles called atoms. At first, not many people believed him. But throughout the course of the 1800s, more and more scientists got on board with his idea. But it remained an open question whether the atoms were really indivisible. Were they like tiny little billiard balls, hard and solid? Or were they made of smaller things? No one really knew the answer to that. But J.J. Thomson was able to answer part of that question when he discovered the electron. He discovered that it was much smaller than atoms. He discovered that atoms had electrons. And so he was able to say for the first time that atoms weren't totally solid and indivisible, but they were made up of smaller subatomic particles. Let's look at how he discovered the electron. So Thomson used what's called a cathode ray tube. It's a big tube of glass that's kind of like a bottle. You can imagine it sort of like this soda bottle. It's sealed all over, and then you pump all the air out of it, okay? And it has these two pieces of metal at this end. So Thomson connected these two pieces of metal to a power source, and here's what happened. A ray shot from this piece of metal across the tube and created a glowing spot over here when it hit a special coating on the inside of the glass. Now, Thomson didn't know what was going on, but what really was going on is that electrons from this piece of metal were shooting out. They were attracted to this piece of metal, which has an opposite charge, but they were moving so fast that they shot all the way across the length of the tube. Anyway, Thomson sees this ray, and he gets curious as to what it's made of. And so he asks the question, the stuff that the cathode ray is made of, does it have an electrical charge? And here's how he attempts to answer that question. He takes two metal plates and puts them on either side of the cathode ray tube. And then he turns on electricity, which makes the top plate positively charged and the bottom plate negatively charged. And check out what happens to the cathode ray. When he turns on the power, he sees that now instead of going straight through, the cathode ray bends up. It bends up towards the positively charged plate. So based on this, he reasons that the cathode ray must be made of stuff that's negatively charged, since it's attracted to the positively charged piece of metal, and he knows that opposite charges attract. But just because he wants to be very careful, he's a very careful guy, he tries to check this another way. So he uses a magnet. If something has an electrical charge and it's moving, a magnet will push it in particular directions. So he takes a cathode ray tube, if you want to think that this marker is kind of the cathode ray tube, and he surrounds it with a magnet, just like this. We can kind of show what goes on by slipping the magnet under like this. So anyway, he puts the magnet here, and he sees now that the cathode ray bends in the other direction. It now moves downward. Now, if the cathode ray is indeed negatively charged, this is exactly how he would expect it to move in the presence of a magnet like this. So this is just further confirmation that whatever makes up the cathode ray probably is negatively charged. So he takes the data that he gets from these experiments, and he's able to draw a few important conclusions about cathode rays and what makes up atoms. Okay, so based on the outcomes of the experiments with the charged plates and the magnet, Thomson is able to conclude that cathode rays must be made of stuff that is negatively charged. Okay. He combines the information that he got from the experiments that I just told you about with some other data that he collected. And he's able to come to the conclusion that the particles that make up cathode rays are 1,000 times smaller than a hydrogen atom. Hydrogen atoms are the smallest atoms. So this thing that's in the cathode rays must be really, really tiny compared to an atom. And finally, Thomson swaps out the type of metal that's in the cathode tube. He uses a variety of different types of metal, but he finds that all of the different metals he uses give off the same cathode rays, and regardless of what metal he uses,
needed to be
the
used.
size of the things that are in the cathode rays is exactly the same. So based on these three conclusions, he's able to come up with the idea that atoms have tiny, negatively charged particles inside them, and these things that we're talking about here are
Possibly.
electrons.
So I say electrons and protons, and that the light is appearing to be bending because of attraction and repelling, but also where the ionized gases are just moving and what's creating the light to shift within the contained environment, and using a power source as well. So you need the power source in order to even get it to function. And so, anyways, he doesn't say this, and so I just wanted to make that clear.
Now, if you're like me, when I first learned this, you might be confused how these conclusions definitely tell him that there are electrons inside atoms. I remember when I first learned this stuff, I was thinking like, wait, doesn't this just show that electricity or cathode rays have negatively charged stuff? How does this tell us anything about the atoms? Okay, here's why. At the time that Thomson does his experiment, everyone, for the most part, agrees that all things are made up of atoms. That atoms are the smallest things that make everything up. They're like the smallest things in the universe. So if Thomson is able to show that there are even tinier things, well, where are those tiny things coming from? They have to be coming from atoms because everything's made of atoms, right? That's the only place they can be coming from. And even if electricity, even if you want to say that, oh, well, he's just showing that electricity is made of electrons, well, then still, where are the electrons coming from that make the electricity? The electrons have to be coming from other atoms. And since he can move or remove these pieces of metal and swap other metals in, and he still gets electrons, it again shows that all different types of atoms are able to release or give off electrons. So they must be in there to begin with. Anyway, these conclusions that Thomson comes to have dramatic effects on how scientists think about what the atom actually looks like. Now, at the beginning of the video, we said that in Dalton's atomic model, atoms are indivisible, that they're not made of anything smaller. But when Thomson discovered that atoms have tiny negatively charged electrons inside them, he essentially disproved this model, at least the part about the indivisible atoms. So here is the model of the atom that Thomson comes up with. He realizes, first of all, that electrons are negative. We already talked about that. But then he notices that on the whole, atoms in general are usually electrically neutral. So even though they have these negatively charged electrons inside them, the atoms as a whole don't have a charge. So Thomson realizes that in order for the atoms not to have a charge, there must be some positive charge in the atom that can balance out the negative charge of the electrons. And then the positive and the negative balance out, and the atom then as a whole doesn't have a charge. So he comes up with a model that he calls the plum pudding atom. Now, plum pudding is kind of a British thing, so if you're American, it might be better for you to think about this as like the blueberry muffin model. And here's how it works. Thomson imagines that the atom is like a blueberry muffin, and that electrons are stuck in this atom the way blueberries are stuck in a blueberry muffin. So you have these little electrons that are stuck in the atom, but then they're surrounded sort of by a dough. And the dough, like in a blueberry muffin, keeps these electrons or blueberries held in place, but the dough itself has a positive charge. And it's that positively charged dough that is what balances out the negative charge of the electrons. And so together, they don't have any total net charge. So the atom is electrically neutral. So that's how J.J. Thomson's discovery of the electrons leads to this plum pudding model of the atom. But now J.J. Thomson didn't have it quite right, because it turns out that the positive charge in the atom isn't sort of spread out in this dough or pudding, but instead it's concentrated right in the center of the atom where the nucleus is. So that's going to be the next step in discovering what the atom really looks like. If you're interested in how scientists disproved J.J. Thomson's plum pudding model, check out Rutherford's gold foil experiment, where he discovers that atoms have a very small, very dense, positively charged nucleus.
Okay, so he's going to go play it, but I just wanted to
in this video, we're going
positively and negatively charged particles and how they interact with the environment based on things like temperature, pressure, and density. And so electromagnetism, depending on those parameters, like the wavelengths, the frequencies, the vibrations, etc., fields will be, so light and sound. So electromagnetism is expressed via light and sound. That's how we see it and perceive this reality. And yeah, so this was
look at how scientists discovered that atoms have a nucleus in them. This discovery was made by Ernest Rutherford.
Gold connected to the seventh chakra, the crown chakra, the color gold, for well, the element gold rather, the color violet, and then you go beyond that to the ultraviolets. But with that chakra, gold, and the sun,
as well as his colleagues, in 1911, and they made this discovery with their famous gold foil experiment, and we're going to talk about that here. So atoms. This is sort of how we think about atoms today, with electrons on the outside, and then in the middle, a dense, hard nucleus that's where the protons and neutrons live. But it wasn't always like this. Before Ernest Rutherford and his co-workers did their experiment, this is what scientists thought the atom looked like. They called it the plum pudding atom. Now, plum pudding is kind of a British thing. So if you're American, it might be better to call this the blueberry muffin model. Think about this. You take a blueberry muffin and break it in half. What do you see on the inside of that muffin? Well, you'll see blueberries, and the blueberries are just kind of randomly stuck into dough. And that is exactly what scientists thought the atom looked like at a very small scale. That electrons were sort of like blueberries, and they were stuck in this dough, kind of, that was positively charged. So you got this positively charged dough with electrons stuck randomly in it. This is the plum pudding model, but of course it turned out not to be true. Here's how Rutherford and his co-workers showed that the atom had a nucleus and that the plum pudding model wasn't right. They started out with a piece of gold foil, which is like tin foil or aluminum foil, except it's made of gold. I mean, wouldn't this be awesome to like wrap your sandwiches in for lunch? Anyway, I don't know, maybe if you're really rich, you use gold foil to like prepare your lunch. Anyway, they took this piece of gold foil and they shot tiny little things at it. What they shot at it were called alpha particles, which are tiny positively charged particles that are much, much, much smaller than an atom. So
which make up most of the radiation belt. These ionized gases that are the lightest on the periodic table, like helium, hydrogen, called alpha particles, etc.
The gold foil, they bam, 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 shoot alpha particles at it. Now they want to know what happens to the alpha particles after they hit the gold foil. So here's what they do. They take a material that flashes when it gets hit by alpha particles, and they take this material and they bend it around into a circle like this. So wherever the alpha particles hit, they'll see a flash. They take this material and then they take their piece of gold foil and they put it right here in the middle of this circle. So now they shoot alpha particles into the gold foil and they'll see a flash somewhere on this circle that will tell them where the alpha particle ended up after it hit the gold foil. Now here's what they see. Most of the time, they shoot alpha particles, bam, 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 here at the gold foil, straight on, and they see flashes right here, behind the gold foil. So this would indicate that the alpha particles are going right through the atoms of the gold foil and are ending
more
up
dense
over here.
In the atmosphere.
So that's the first thing they notice. The second thing is a really huge surprise. when they shoot the alpha particles, every once in a while, they don't see a flash here. Instead, they see a flash over here, or a flash over here, or sometimes a flash here or here, which makes them think that the alpha particles are hitting the gold foil and are veering off to the side once in a while. Or sometimes they're hitting the gold foil and they're bouncing back completely all the way back. So we can kind of summarize what they see using a diagram like this. Here we've got our circular detector screen that flashes. Here's an alpha particle emitter, which is just a fancy word for an alpha particle gun, something that's shooting alpha particles. Most of the time, these alpha particles hit the gold foil and they go right through, and we see flashes on the screen on the other side. But every once in a while, an alpha particle will hit the gold foil, zoom, zoom, and will veer off to the side and flash over here. And every once in a while, it will hit the gold foil and will bounce back almost 180 degrees. Flash here and flash here. So, based on these two pieces of information, Rutherford and his team are able to make some conclusions about what the atom actually looks like.
We have different opinions that
Here's
I want
the
to unpack.
conclusions that they come to. Let's start with this gold foil, okay? The gold foil that they use is incredibly, incredibly thin.
Yes, it is.
In fact, it's so thin that these guys reason that there are only a few atoms in its thickness, that it's only a few atoms thick. So let's look at it on its side here and look at a magnified view of the gold foil. If we want to think about gold atoms as being sort of circles or balls, this is what the view from the side of the gold foil might look like. Just 2 atoms thick here. Now, let's think about the results that they got from the gold foil experiment, okay? The first thing that they saw is that most of the time, the alpha particles seem to have gone straight through the gold foil. So, based on this information, they're able to reason that most of the atom is empty space. Or if there's something there, it's very light. It's not very dense, and it's really easy for the alpha particles to shoot right through. So most of the atom is probably empty space. But now the second thing
I don't like that
they
term,
see
empty space.
is that every once in a while, an alpha particle zoom, veers off to the side, or it's like it hits the gold foil and bounces back. And so based on this information, they reason that while most of the atom is probably empty space, they think that there must be something very small but very hard inside each atom. And here's a drawing here. Of course, you know that this is the nucleus now, but they didn't know that the nucleus existed, so they had to discover it here. And so they think there must be something really, really hard. And when an alpha particle hits it head on, bam, that alpha particle's gonna ricochet back. And they also notice, as we said, that sometimes the alpha particle veers to the side. They say, well, maybe it's because it hits the nucleus on the side of it, so it goes off like that. Or they also said maybe since alpha particles are positively charged, maybe the nucleus is positively charged, so that if the alpha particle comes close to it, remember, things that have the same charge repel each other. So you've got this alpha particle coming close to a positively charged nucleus, then zoom.
See, that's where we
to the
agree.
side.
Magnetically or positively charged, because I say positive, negative, electric, magnetic, that's creating that repellent. So that's where I think it is possibly more dense as well. All of these things obviously are also impacted by temperature, pressure, and density. I wanted to get into when he's saying empty space. I've shared as well where there have been people doing simple experiments using some kind of a fluid, but with iron filings in it, and then using a magnet to like move over this fluid, and you'll see that the iron filings will get attracted to the magnet depending on how it's polarized. That matters as well. And but that doesn't make it where the areas beyond the fields or these filings are empty space. There's still fluid throughout. It's just less dense and has less of a pull or an attraction towards the magnet. And so, but still matter, still particles within that as well, and then inside as well. It wasn't like all the matter wasn't just removed magically out of the center of the field. I hope this makes sense to people, and how it's like at the center plane of inertia where there's the attraction or repulsion that's happening depending on, again, depending on what type of structure it is or particle it is, and if it can be positively or negatively, electrically or magnetically influencing its environment.
Because they're pushing away from each other. So regardless, based on this information, they reason that there is something small and hard in the atoms that once in a while the alpha particles are banging into, and that's what's causing them to bounce back or to veer off course. And they also reason that whatever this nucleus is made of, it's probably positively charged because of the way it looks like the alpha particles are sometimes getting repelled and pushed away. So if you take these two pieces of information together, we can come up with a model for the atom that looks like this, where this is just a combination of those two things that I saw, where we've got these gold atoms lined up, and most of the time, if alpha particles pass through so they don't hit any nucleus here, they just go straight on through. But if an alpha particle hits this hard, dense nucleus, or is close enough to be repelled by its charge, it veers off or it bounces back. So here's how the gold foil experiment changes how scientists think about the atom. Okay, so as we said before, here's a plum pudding atom with these electrons stuck in a positively charged kind of pudding. But Rutherford's experiment shows that this isn't quite true. Instead, he comes up with a model like this, where there is a hard, dense nucleus in the middle, and that is where the positive charge is. So the positive charge isn't like this kind of blueberry muffin dough that's spread throughout the atom, but instead the positive charge, everything that I've drawn in red here, the positive charge is concentrated right here in the middle of the atom. And then there might be some electrons floating around on the outside, but they're certainly not held in place because of the positively charged dough. Now, this is just one piece in a puzzle of figuring out what the atom actually looks like. So shortly thereafter, Rutherford comes up with this model for the atom, but then scientists realize that the electrons probably aren't just stuck in place, and instead they think that the electrons are spinning around the outside of the atom, and you still have this hard, dense nucleus in the middle. And then only a short while after this, it's discovered that the nucleus isn't just a hard piece of positive charge, but that the nucleus is actually made of protons, each one of which has a positive charge, and then the electrons are spinning around the outside. Now, this is what we call the nuclear atom, because it has a nucleus. So we've got the nucleus of protons, and then electrons spinning around the outside.
Yeah.
But of course, you probably know this still isn't an accurate representation of exactly what the atom looks like. In fact, they're totally missing the neutrons. It wasn't until the 1930s that James Chadwick and his colleagues discovered that there are neutrons, neutrally charged subatomic particles, in the nucleus of an atom. And then, as I've alluded to before, it's not that the electrons are really spinning around in circular orbits, but it's more like they're just buzzing around like crazy hyperactive flies all over the atom. But we'll get to all that later.
In circular orbits.
For right now, all you need to know is that Ernest Rutherford's gold foil experiment showed that the atom was mostly empty space, but that it had something hard, something dense, and something positively charged that the alpha particles sometimes hit and bounced back.
Yes.
Now, I want to talk about one more thing that can be confusing, but it's really important. And it has to do with the predictions that Rutherford made, what he was expecting to see. Okay, now when people first learn about the gold foil experiment, they're often really shocked that the alpha particles went straight through the gold foil. And they think that Rutherford and his coworkers must have been really shocked as well when they found this out. But it turns out that Rutherford was actually expecting the alpha particles to go through the gold foil. He thought that if atoms were the plum pudding model, that the alpha particles would have gone straight through. Because he thought that this positively charged dough was so light that the alpha particles would just be able to pierce right through it like bullets through a giant blueberry muffin. And sure, there are some electrons there, but compared to an alpha particle, an electron is so tiny, it's like a poppy seed compared to a bullet. And so he thought that that bullet would just fly right through the plum pudding atoms. Now, if you want to think of a model of the atom that would have made the alpha particles bounce away, it would have been Dalton's model, which was one of the first models of the atom. Dalton thought that atoms were hard, indestructible balls. And so if atoms had really been like Dalton thought, sure, the alpha particles would have hit them and would have bounced away. But if the atoms were the plum pudding model, because this positively charged dough is so light, Rutherford thought that the alpha particles would go straight through. So when it turned out that the alpha particles went straight through the gold foil, it wasn't really that much of a shock. But what was a shock was when sometimes the alpha particles would veer off to the side or would bounce back. This is what was really shocking. And it told Rutherford that instead of the positive charge being distributed throughout in this kind of dough, that the positive charge was concentrated here in the nucleus. So that's what led them to the model of the nuclear atom with a nucleus. So it might even be better to draw the nuclear atom like this, where instead of having this pink positively charged dough, there really isn't anything here at all. And it's just all of this positive charge is focused right here in the middle of the atom. Now, it's almost not even good to draw these atoms as if they're shells with a nucleus in the middle, because it's not like they have shells.
Okay, so I'm not going to lie, my brain was somewhere else. I was thinking about the cathode ray experiment again, and then just the type of container that was used, and just how when you manipulated the cathode ray, the anodes, and then the materials that were being used to impact the light or the laser. Because, by the way, these rays also emit heat spots in areas of the Terrella experiment that I'm going to share. Anyways, I can't get off track. But, and so how it was curving upwards, depending on the charge, whether it would be like positively or negatively charged, and in interacting with the ionized gases from within this cathode ray. And so you see the curve because of the shape of the cathode. But if it was like a donut shape, or kind of like circling around it like some kind of a circular tube, then you would see that the light would bend in a circle. And so I would like to see more experiments on that. I'm sure there's plenty on the interweb. And so that's going to be another rabbit hole I'm going to go in. And so anyway.
More accurate way to talk about this is to say that the shells, what I'm drawing as the shells, are really just the outer limits of where the electrons go, okay? And so what's between what I'm drawing as a shell and the nucleus is really just where the electrons live, but they're tiny and they're moving around all the time, so there's really not much there. So in fact, maybe one of the best ways to draw the nuclear atom would to be like this, where there isn't a shell, but there's a nucleus in the middle of each atom, and then you can kind of see a circle here, which is the outer reaches of where the electrons go. But then, of course, this isn't a perfect view of electrons, because instead of going around in circles, they sort of buzz around in various shapes. But again, that's getting a little ahead of ourselves. What the main important points are here is that Rutherford's gold foil experiment disproved the plum pudding model of the atom. It wasn't that there was positive charge all throughout the atom, like the dough in a blueberry muffin, but that it was the positive charge was heavily concentrated in a very hard, very dense nucleus in the middle of the atom, and then the electrons were on the outside of it. So that is how Ernest Rutherford, Hans Geiger, and Ernest Marsden discovered the nucleus with their gold foil experiment.
All right. I'm going to close this down for now and share some of the visuals of Brooklyn's experiments. Northern Light.
Welcome to the Norwegian Museum of Science, Technology and Medicine, home of the Oslo Science Center. My name is Andre, and today we are going to talk about the Northern Light, or Aurora Borealis, and how it was recreated in the laboratory in the 19th and very early 20th century. This is a mid-18th century experimental device called a lightning tube, where we can see electric sparks in air. And this is one of the predecessors of the later vacuum devices, where we can show the same electric discharge in a partial vacuum. Early glass tubes for making discharges in vacuum were usually used directly on the vacuum pump. But in 1857, Heinrich Geissler in Germany invented the Geissler tube, which is a closed tube, a small evacuated space where we can create a pinkish purple electric discharge, which can be manipulated with magnets and in other ways. Norwegian professor Christian Birkeland was fascinated by electromagnetism, and he showed this experiment using a slightly different vacuum tube in a famous lecture in Oslo in 1896. In his later research, Professor Birkeland refined this experiment, eventually creating more than a dozen different instruments.
I think a lot of these experiments are flawed based on people's interpretation of the cosmos and the shape of the Earth. And so, yeah, it's hard without a frame of reference, but it's good to show the these experiments anyways, even though, again, like even the model itself is flawed. It should be, like I was saying before, cathodes being projected possibly from like these spherical objects or these luminaries from above us onto the Earth plane that is magnetized, and then being able to look at the fields that are created, these toroidal fields of our interpretation of this cosmos. And yeah, there's so much I can talk about, but
which were all used in this increasingly advanced studies of the Northern Light. This is the last and most famous of these instruments, built in 1912 or 1913. It is a vacuum chamber of approximately 1,000 liters capacity, with a Terrella or magnetized model of the Earth inside. An engraved image of the instrument was featured on the Norwegian 200 kroner paper bill from 1996 to 2017. And today we often talk about this whole apparatus as a Terrella, and not just the magnetized sphere inside. In 2017, we celebrated the double anniversary of 100 years since Professor Birkeland's death and 150 years since his birth. Oslo Science Center built this replica of his large Terrella chamber, which you just saw. And we will end this little presentation by showing you one of Professor Birkeland's most famous experiments, the Northern and Southern Light auroras, shown as the polar light ovals inside the chamber. If you are ever in Oslo, please come and try it for yourself.
yeah. So the shape, the model is flawed, which is frustrating. But I do like the interactions of the light. That's just showing that these luminaries do have an impact on the not only the constellations, but the lights in the sky. These light shows that we see. All different gases that are interacting with these different lights, these different beams of light, whatever they be created from. Okay, so I'm going to be doing some reading. I don't know how much, but first I'll show you this archive book that I found. Okay, I'm on page 74 of almost 1,000. Frig. The Norwegian Aurora Polaris Expedition, 1902-1903. And so I do think, and I'm going to reiterate this, that the extremes that the luminaries travel, especially the sun and the moon, creates these different light events, whether it be in the north or the south, and it has nothing to do with the shape of the Earth when I talk about this stuff. And because as the sun travels the Tropic of Capricorn, this longer ring circuit above us, more localized within the sky, it is 23.4 degrees south latitude of the equatorial ring when it's closer to the regions that are more south. And when it's traveling the Tropic of Cancer, that's when it's closest to people in the north or the center of this Earth plane, this plane of inertia. So, anyways, this is a really interesting book. Talks a lot about his travels and his failures during his first ventures to these observation posts or locations, like really, really high up on mountaintops in the north, in Norway and in other areas. And a lot of mathematics. He shares all the information on the equipment he used, the resources he used, the tools he used to do all the measurements, temperature measurements as well. And yeah, just very fascinating. I'm not going to go through the whole thing, but yeah, I will be reading this book. It's a long read. But then I found this paper from HAL Open Science, the Birkeland Terrella experiments and their importance for modern synergy of laboratory and space plasma physics. K. Ripedahl T. Brundtland. I'm probably mispronouncing that. Okay, so a study of the evolution of Christian Birkeland's theories of cosmical physics is presented with special references to his laboratory gas discharge experiments. I was very interested in that. It is found that his most important thoughts were molded from an intense cross-fertilization between laboratory experiments, geophysical observations, and mathematical modeling. Occasionally, original ideas of fundamental importance in the cosmic context emerged from unexpected laboratory results. Possible implications for a sound cross-disciplinary approach to modern plasma science are discussed. Okay, so it says here, although plasma physics emerged as an independent physical discipline as late as the 1950s, the roots can be traced back to the 19th century, and I'm saying even earlier than that, lost knowledge. Even to the time before the electron was discovered by J.J. Thomson in 1897. At that time, one did not have a clear conception of the fourth state of matter, but a few great scientists developed through laboratory experiments in discharge tubes and geophysical observations fundamentally correct ideas about the plasma nature of the sun, the interplanetary space, and the solar terrestrial interaction. A giant among these visionaries was the Norwegian physicist and inventor Christian Birkeland, 1867 to 1917, whose outstanding scientific work has received increasing recognition throughout the last 2 decades of active space exploration. Even though modern space science continues to rediscover the deep truth of many of Birkeland's ideas, an even more interesting aspect of his work may be his interdisciplinary approach to scientific exploration. He acquired and processed information from a number of research disciplines which today are virtually non-interacting. I do agree with that, because even now I would say it's even worse. So Birkeland acquired and processed information from a number of research disciplines which today are okay, I already said that. All right. During the first decades after the end of World War II, plasma science emerged as a new field that unifies the fundamental disciplines of electromagnetic theory, statistically mechanics, kinetic energy with astrophysics, space physics, and material science. However, in the last 20 years, there seems to have been a decline of consciousness about plasma science as an independent but unifying scientific discipline. There has been a tendency towards fragmentation of plasma science into specialties like fusion plasma, space plasmas, weakly ionized laboratory plasmas, and industrial plasma processing. And many plasma physicists find it easier to market themselves to the funding agencies as fusion scientists, space physicists, and so on. This in turn leads to reduced emphasis on basic plasma physics, to more specialized journals and conferences, and to reduced interdisciplinary science is to regain faith in the interaction. The main lesson we can learn from Birkeland and the other great founders of plasma science is to regain faith in the unity and basic nature of our science, and to strive to tear down the walls that are erected between specialized areas. I totally agree with this. Yeah, okay, so December 13th, 1867. University of Christiana is where he studied. immediately started doing experiments on gas discharges in cathode rays. In 1896, he performed experiments where cathode rays were attracted by a magnetic pole, and he could produce a glowing light in the vicinity of this pole, reminiscent of the northern light, polar aurora. This observation made him state his auroral hypothesis. The aurora must be produced by cathode rays attracted by the Earth's magnetic pole, I say pole, and in some way or another, or again, this could be, again, a magnet that's positively and negatively charged. So that would be bipolar. Anyway. But not a globe, not a wet whirling rock spinning through friggin' space with people and everything that's in existence, like outside this cosmos or this dome. No, within, on the plane of inertia. The formulation of this hypothesis initiated an extensive experimental, observational, and theoretical program to unveil nature's secrets about the origins of auroras, geomagnetic storms, the nature of solar activity, comets, planetary rings, and even the origin of the solar system itself. I wish I would have known this guy during this time and went to school with him. Knowing what I know, maybe I wouldn't have known it at this time. Okay, so organized 3 expeditions to the Arctic to make geomagnetic and other geophysical measurements. 4 different laboratories set up. Okay, so these data were combined with data from a large number of geomagnetic observatories around the globe, not a globe, and with results from laboratory Terrellas experiments, and made the foundation for far-reaching theories about the cause of magnetic storms and terrestrial magnetism. This work was summarized in an 800-page treatise. The first part was published in 1908 and the second in 1913. The first series of Terrellas experiments were performed in glass tubes of variable shape and size in the period 1900 to 1908. They were conducted in between and after the Arctic expeditions and were obviously a very useful tool for Birkeland when he was striving with making sense out of the extensive mass of geophysical data acquired. During the work with the second part of his treatise, he felt constrained by certain limitations of the small glass tube experiments and started to build a series of box-shaped chambers with flat glass walls. Experiments with 4 different box chambers of increasing size were conducted in the period 1908 to 1913, and the results were published in the second part of his treatise. Okay, what did you learn about his cathode rays? So Henry Poincaré. So the equation of motion for a charged particle in a magnetic monopole. So that was very interesting to me. Birkeland elaborated further on this problem in an experimental and theoretical paper from 1898. I want to see that. The monopole problem is integrable, but the corresponding dipole problem is not, and it was the problem Birkeland wanted the gifted young Stormer to solve. For Stormer, this task became a lifelong enterprise, and his calculations became a cornerstone in Birkeland's theories. During his entire career, Birkeland spent a lot of time on practical industrial research and technical inventions. Among his most famous inventions are his electromagnetic gun and the development of a plasma furnace for oxidation of the air's nitrogen. Wow. 1 second. All right, which soon was developed into one of Norway's most profitable industries. Bunch of patents all over the place. Siberia, Japan, Europe. Okay, so when Birkeland came back to Norway in summer 1895, he had become very interested in gas discharges, which was a popular field of research at the time. He obtained a position at the university at an age of 28. Okay, so he began to prepare a course in gas discharges and experiments with a planned start in February 1896. The new rays discovered by W.C. Röntgen in Germany. Okay, Birkeland demonstrated X-rays for a group of engineers, physicists, and physicians. He gave a public performance where he could also demonstrate artificial northern lights. So these are the rays, artificial auroras. So air glow in stripes as the auroras by magnetic influence on cathode rays. He also suggested to send photographic plates only sensitive for cathode rays up to high altitudes with balloons to investigate the relationship between aurora and cathode ray. So we were on the same page. Anyway, he described several different experiments with gas discharges. The paper dealt with magnetic lenses, magnetic spectra, and discharges that have a remarkable resemblance to the aurora borealis. In one experiment, he was able to focus the cathode rays by external magnets to the size of a needle point on the inner side of the glass wall. The action of such a beam was so intense and hot that if it was allowed to travel over the surface of the glass by moving the magnets, it left the mark of its track by splitting off gas particles from the wall. In this way, writings could be etched on the glass. Birkeland was easily able to write his initials KRB on the inside. The discharge tubes used for these experiments are shown in Figure 2. They were very important results in themselves, but the most far-reaching consequence of this experimental work is contained in the interferences drawn in the last paragraph. So several times phenomena have been described which show that cathode rays are drawn towards a magnetic pole. This observation is considered to be of interest in the connection with the theory of the aurora borealis. Paulsen, the Danish meteorologist, considers that the aurora borealis is due to the phosphorescence of the air by cathode rays in the highest strata of the atmosphere. The greatest difficulty in this theory has been to explain why these displays are confined to a zone surrounding the magnetic pole of the Earth and from whence the energy comes which gives rise to these rays. After what has been said above, it may be assumed that the rays are attracted to the Earth's magnetic pole, and that in some way or other, the energy is derived from the sun. The latter hypothesis is at least supported by the fact of the diurnal variations of the northern lights and the cyclic changes which correspond with the 11-year periods of maximum solar activity. So the hypothesis stated above was not entirely new, although it was competing with a wealth of other colorful ideas, I like that term, colorful, about the origin of the aurora. Becquerel suggested that particles were shot off from sunspots and were guided by the Earth's magnetic field to the auroral zone. A similar idea was proposed by E. Goldstein. What distinguished Birkeland's hypothesis from the others is that he was guided by controlled experiments. This made his idea more than a suggested explanation of a phenomena. It was a hypothesis formulated for immediate experimental test, and for 2 decades to come, it guided him through what perhaps was the most extensive experimental and observational program in the world to that date. In the first years after the auroral hypothesis was formulated, Birkeland conducted more laboratory work on cathode rays and magnetism. He had several publications on the subject, but he was also studying sunspots and cosmic phenomena, what we're calling cosmic phenomena. Okay, that his classic paper on the nature of the cathode rays from 1897 has taken some of his discoveries from this period as a starting point when proving that the atom is not the smallest unit of matter. Very interesting. Okay. The produced bands present then such an analogy with the auroral bands that when witnessing this experiment, no doubt it is possible we see the evidence that the two phenomena are strongly related. After 4 years of hard work with classical gas discharge tubes, studying X-rays influence on cathode rays by magnets and discharges which resemble the aurora borealis, not entirely, because again, he doesn't have the most accurate models, he now turned to a new class of experiments, greater ideas, evolution of experiments and ideas. Short description of Birkeland's second expedition to the Arctic. I read a bit of that. Okay, published next spring in a chapter. He named the spherical Electro Magnetic at Terrella, Little Earth, after the small magnets or lodestone used as Earth's models back in the 16th century by William Gilbert. Interesting. The idea of using a magnetizable sphere in a gas discharge opened up a new and great field of research for Birkeland. Almost all of his future laboratory physics would be focused on this miniature Earth. Again, it's showing the shape of the toroidal fields that surround this Earth. So again, it's a false model, but if you're going to look at the fields themselves, like where we're living, I'm going to reiterate, is at the flat plane of inertia from within inside of that. But still very interesting. So in addition to studying for artificial aurora, he also used the Terrella for simulating solar phenomena, comets, and the rings of Saturn within a contained environment. Again, very, very interesting. All right. Model showing Professor Stormer's calculated trajectories for the experiment. The auroral zone, the calculated trajectories are for particles starting out in a slightly different directions at a position corresponding to the cathode and with energies corresponding to the discharge voltage. So they were playing around a bunch with multiple cathodes and anodes, dimensions, different types of materials being used that are more electric or magnetic or neutral. Solar and cosmic phenomena. He started up with some quite new experiments in the 22-liter chamber, now simulating the sun, Saturn, and comet tails, gaseous discharge, or magnetic interruptions. Okay, so the Terrella, which was without phosphorescent coating, was now negative and served as the cathode, simulating the sun. So they even reversed it. Okay, so in several of his auroral experiments, Birkeland had come upon phenomena which could serve as a starting point for an explanation of the zodiacal light. Very interesting to me. This light is a glow which appears in the western sky after sunset and in the eastern sky before sunrise, at lower altitudes, or latitudes, I mean. He believed that this light was also due to discharges as the aurora, and tried to simulate this in his laboratory, again using the incorrect model. So this experimental setup was very similar to the one for the aurora, but the polarity of the discharge was changed. The Terrella, which was without phosphorant coating, was now negative and served as the cathode, simulating the sun. In his interpretation of the sun, he used 1 or 2 aluminum discs for anodes. As far as can be ascertained from the text, this was his usual way of connecting the apparatus when doing experiments simulating zodiacal light, sunspots, and the rings of Saturn. These gaseous discharges that are in a specific area. He also experimented with using the metal parts of the chambers as an electrode. His explanation of the zodiacal light was that clouds of atomic dust or particles, gaseous particles originating from the sun, were spread out in a very thin layer in the sun's equatorial plane and were illuminated by some sort of cosmic discharge or gaseous discharge. He demonstrated this for the first time by running discharges with an 8-centimeter Terrella. With the Terrella highly magnetized and with a low discharge current, he could create a flat, thin, luminous discharge in the equatorial plane of the Terrella. Flat, thin, luminous discharge. Anyway. Under ideal conditions, he could produce, that's the plane of inertia I'm talking about. He could produce plane rings sharply intercepting the glass windows. He wrote that if he could have been in possession of sufficient quantities of pure radium bromide, he would have coated the equator of the most highly magnetized Terrella and observed whether rings, rays, alpha gamma rays, I think, beta, anyway, I don't know, would develop in addition to the rings of cathode rays. Very interesting, because the luminaries, again, emitting this light. This comment reflects the prevailing conception at the time of matter as composed of neutral atoms and the 3 known types of corpuscular rays, what we're calling rays. These beams of light. Particles. Radiating. Later, however, Birkeland expressed ideas about interplanetary matter, which was much closer to the modern concept of dusty plasmas. Calling particles dust. Gaseous ionized gases interacting with the various types of rays that are being utilized. Okay, so the rapid disintegration and light emission from the carbon confirmed Birkeland's idea. Okay, wait, I missed a part here. He suggests that the comets approach the sun. They are discharged to a high negative potential by cathode rays emanating from areas around the sunspots. And an anode-cathode relationship is set up and a visible discharge takes place in the outstreaming gas from the comet core. Also, this theory was tested in the laboratory. It was believed that the comet cores were carbonaceous, and he performed numerous discharge experiments with carbon in different forms over a metallic cathode in the vacuum container. The rapid disintegration and light emission from the carbon confirmed Birkeland's idea that the visible tail is formed by the outstreaming gas ignited by a discharge. He also simulated the comet with a very thin, hollow silver needle penetrating into the vacuum chamber from the outside. That's very interesting. With the pumps in action and blowing a weak stream of CO2 through the needle into space, he managed to set up a discharge between the needle and the anode, the needle acting as a cathode. By carefully adjusting the gas flow and the discharge voltage, he could get thin pencils of light shooting out from the comet. All right, so in the description of his first Terrella experiment, he mentioned that he, in some experiments, had seen 3 luminous rings around the Terrella. In addition to, I wish people could do this on a proper model. That would be very interesting. In addition to the rings in the polar regions, he had sometimes been able to observe a third one that encircled the Earth model, almost like the rings of Saturn. Later, during his systematic studies of laboratory aurora, he now and then described the phenomena, which was rather difficult to produce under his standard experimental conditions. Okay, so systematic simulations of the Saturnian rings discovered that they were easily formed by changing the polarity of the discharge. In fact, this was the same setup he used for simulating the zodiacal light, but the discharge parameters were different. Discharges consisting of 3 and sometimes as much as 5 equatorial rings around the Terrella. That's funny. Because again, these multiple ring paths that they take above us. People like Eudoxus said there was 27 ring paths or whatever. And anyway, several experiments in an evacuated bell jar placed in a strong magnetic field. He investigated the disintegration of palladium cathodes in a powerful discharge and the deposition of the palladium on the glass walls. Anyway, this is a lot to read. I'm halfway through almost. And so I hope this is making sense to other people. On that note, I'm gonna carry on. So my next video, I'm gonna continue reading off that dissertation, whatever you want to call it. And I'm gonna find some good parts of the book that I'm reading as well. It's almost 1,000 pages, but some very interesting portions that I like out of that archive book that again connect more dots and how I see this Earth plane as as how to describe it, I guess, without too many frames of references. So on that note, I'm rambling on. I will leave it at that, and I hope that everyone has a wonderful rest of your day.